let's kind of get right into it. So the first thing I want to look at is this sample file here. Okay, this is one of the help topic files. There's a tutorial on it, and essentially we're dealing with a step shaft that has a bunch of different holes in it. Okay, so when we're talking about drilling, where do you find your drilling features? Again, we're in a milling job. We have a 4-axis generic Fanuc machine. We have our setup located on center at the base of the part here, and essentially we want to drill some of these holes. Okay, so in with drilling the holes, we do have a cross drilling operation, and the cross drilling operation is a great way to find and drill holes faster, especially when you're dealing with holes that intersect with the axis of rotation or holes that are on center. So one of the things that you're going to notice right away is all the holes that are selected here and that are being machined. The center line of that hole is going to intersect the axis of rotation. Okay, so everything's on center here. All of these holes that are off center or on a different angle, you can see that they're avoided. Okay, and the reason why I'm bringing this up is it does make it really easy for selection. Okay, so let's go ahead and get rid of this guy. This other routine here, this is kind of a 4-axis pro toolpath, right? So, when we look at 4-axis standard, you get indexing, wrapping, and rotary. Okay, so if you're in your setup here, you come down, you can add an index system, you can add a wrapping group, okay, and then you also get rotary. So if we come in here under 4-axis rotary, if you're a mill standard user, you would get this 4-axis rotary. Now, if you're a Mill Pro user, okay, that's going to unlock these additional advanced rotary toolpaths. The first one is Z-level roughing for 4-axis. The second one is Z-level finishing for 4-axis. And the third one here is a combo routine. So these are some of the toolpaths that you get becoming a pro user. Okay, some of the other toolpaths you might get becoming a pro user ends up in this multi-axis arena. Okay, so if we come down here to multi-axis, you're going to see things like deburring. Deburring is available in 4-axis pro. Turn milling, which is different than rotary. The big factor here is off-center cutting and adjustments. There's a popular toolpath for chip slinging powerful end mills, right? And then the other thing you get is all these surface-based toolpaths, okay? And when you go 4 Pro, you get these, you can use them in 3, 4, and if you go 5 Pro, you can use them in 5-axis. So kind of talking about the differences between, standard and pro. And if we're talking about drilling, let's kind of take a look. So the first way you might approach a job like this would be to set up an index system. And sometimes, that could be, a little confusing. How do I don't have a planar face that I can work on to pick from. Okay. So if we want to set up an index system, we can right click on our setup, go to additional functions, and you can go add index. Okay. The other thing you can do is you could add one from up here as well. Okay. So those are 2 areas where you can go to add an index. Excuse me. All right. So if we want to drill this hole, if we look at our Z is going up in this direction. So we would need to rotate the part in order to drill this particular hole right here. Okay. So if we want to index the part, we create an index system. Right now, I don't have a planar face to select on for the index system. So how might we do that? Well, if we right click and we go in here and we do add index, we can either use a surface or we can use a coordinate system. So if I try to pick a surface, in this case, it's kind of finding the middle of that surface. So it ends up lining up with that hole, but that just happens to be by accident. If I chose a different surface, again, I believe what it's finding is the middle point of that surface, and that becomes that index location. Okay. So on a round shape like this, it may be, not apparent how you would set an index system for here. If we pick this cylindrical tube itself, it will be pointing out from that surface normal. So that method wouldn't work either. Okay. So what would be the way to go? How would you do this? Well, instead of using by surface, we would use an index system, or I'm sorry, a UCS. So we're going to come over here, and this is where your user coordinate systems are located, and these are the default ones, okay? We want to create a new one, so we could right-click, add new UCS, and one method of doing this might be just to rotate the UCS itself, okay? So if we look at the coordinate system over here, this is the orientation. So if we look at in X, right? Maybe we want to go 90 degrees in X to clock to that hole. So we could say 90 in X. Okay, so you can see Z is pointing in the same direction as that hole is now, and we could say okay, and then cancel. All right, so now we've created this this coordinate system over here, and then we could use that in order to pick our index system. All right, so we could say add index. We're going to pick from a UCS, and then we'll grab the one that we created. All right, and then now what that's done is clocked the part. So this orientation is the same. So then I could come in child to this index system and just create a drill feature. All right, so we'll select it. You know, maybe we'll pick the tube there. You can see we get a nice preview, so we can see what direction it's going and what its depth is. Okay. From there, we can add an operation. I'm just going to compute it, and you can see how we drilled this hole. So that's one way you could do it, is by rotating the coordinate system itself. Let's look at another method. Okay, so let's go back to the top UCS here. Let's say we're going to rotate the part, and we want to index to this whole location. So we're going to right-click, add new UCS. This time we're going to say cylindrical face, and we're going to pick this tube. Okay, so by picking that tube, in the past, in older versions, like a 31 or maybe further back, it would say 1 or 2, like for the top or the bottom. That doesn't seem to be the case right now. We just have a single selection. In this example, we're just looking at clocking Z, so we really just want the Z direction to be pointing the right way. Okay, but if you needed to modify this location, if it was on the top or bottom, you know, if you wanted to change the Z position of it, you could always use modify as well. We can click modify, and then we could change the XYZ value for it. Okay, in our case, we're going to leave it as is. Maybe I'll give it a different name. We'll say 2, and then okay. All right, so now I've created a UCS from that cylindrical face. So the intention there is when I'm creating my index system, I want to use that UCS. Okay, so that's another way to do this. Again, I'll remove my geometry, reselect, pick the tube, compute, and then now we're drilling from there. Okay. All right. So now you can so we have a couple of these. So we clocked it to a certain position. We created UCSs 2 different ways. Keep in mind, once you have one of these programs, you could create a pattern for it, right? So we could right click on the index system at a parent level, right? So in other words, all the child features would get patterned as well. So we're going to right click on the index system, come down to additional functions, add pattern. We're going to do a rotate, and then there's a 3D option here. And essentially, it's looking for a center line. I don't have one to reference, and I'm not positive of the Z, so I'm going to just leave it where it's at now. We're going to say 3 copies, and I'll say 20 degrees. We'll say OK, and we can see where it's rotating around currently. Its axis. So what we need to do is pick a center line in order to kind of teach it what to rotate around. So I'll go back in this top UCS. I'm just going to draw a line. You know, it just needs to be on center. Okay. So we have that line, and this allows me to reference those point locations. So we'll say pick point, because it's not always clear to me what this value would be. So I like how I can pick these reference locations, and pretty much it's just the Z that we're trying to pick up here. Okay, So once we have that, you can see the Z value. This is so it knows how far from where it's located down to center line. We'll say 3 copies there. And now you can see it's drilling, around in a pattern. Okay, so again,